Today we are going to start a new series of OpenShift. So in these sessions we will look the OpenShift deployment in detail. So today we have to understand the OpenShift installation. A lot of people ask me about the OpenShift deployment process. So there are different methods. So today I am going to explain the Red Hat OpenShift administration. And the very first step is you must have a OpenShift cluster up and running. So to install the cluster, there are multiple ways. So I will discuss today the UPI, user provisioning installation online method. There is another method, IPI, infrastructure provision installer. So in that IPI method, OpenShift will automatically configure your whole infrastructure. You have to provide some manifest that will contain all the compute resource and requirements and your hypervisor or whatever the cloud you are using. So it will automatically provision the infrastructure too. But UPI is a method where your infrastructure is already configured and you just want to deploy the OpenShift on top of that. So, what infrastructure specs I am going to use for this method? Hardware specs I will use HAProxy. It's 1 GB RAM, 20 GB disk, 1 CPU, and 2 CNIC. And master nodes, 3 master nodes I am going to configure because OpenShift cannot install less than 1 master node, and minimum 3 master nodes are required. You can go up to 5, 7, or 9. And 24 GB each I will use RAM, 150 GB disk, and 4 CPU and one network interface card. Similarly, worker nodes that will hold the application load. So I am giving the 32 GB of memory and 200 GB disk and 4 CPUs and one network interface card. So for this whole infrastructure, what I am using, you can use the bare metal servers, physical networks, cables, switch, and let me explain you how this whole infrastructure is going to work. And for in my lab, what I am using, I will use this. I am using the ESXi hypervisor. So let me just log in on this one. So here I have about 250 gigs, 256 GB of RAM, about 1 TB SSD, and I have more than 16 CPUs. So this is a good machine. So I will set up virtual machines on top of this hypervisor, and I will create multiple network switches to make the connectivity, and will deploy the whole OpenShift cluster. So if you want to deploy the OpenShift using UPI method, you can use the same installation process what I am using. Just replace the virtual machine with the physical servers. So rest of all is everything same. So now I will explain you. This is my hypervisor, and this is the network infrastructure of OpenShift deployment. On the top or on the right side, you can see there is an OpenShift net. This is a virtual switch in the ESXi hypervisor. All the master and worker nodes are connected with this OpenShift network, and this OpenShift network is connected with the load balancer. For the load balancer, we are going to use a Red Hat Enterprise Linux 9. You can also use CentOS. And this load balancer will actually be configured by the HAProxy, and it will also serve the DNS, name to IP resolution of all these master and worker nodes. That is a requirement of OpenShift cluster deployment. The DHCP, the automatic IP allocation based on the MAC address binded in the DHCP server. So each machine will automatically fetch the IP from DHCP every time the fix IP because it is binded with the MAC. And this network interface that is connected with the OpenShift network, I am using 10.10.10 0/24 network. You can use any network, whatever you feel convenient. And this interface of the load balancer has an IP 10.10.10.1. This will be the gateway of whole OpenShift cluster, all the worker and master nodes. So I am using two worker nodes. You can deploy more than two worker nodes too. So it depends on the whatever application you want to deploy. And the second interface of another interface that I attach with this load balancer is connected with the internet. My LAN IP that is having the internet access is 1.2.3.0/24. I allocate 50 IP from that series. On this WAN interface, it has a gateway 1.2.3.4 that is connected with the firewall, and this is a WAN network. These two networks are residing inside the ESXi hypervisor, but this WAN network has a physical connectivity to the external physical networks. But this OpenShift network is only residing inside the hypervisor. Its purpose is to just connect all these six virtual machines. And this WAN network is actually connected with the physical network with my firewall. I am using Fortinet firewall to make it connectivity, and a public IP is also landed on my firewall, and that is connected to the internet. We will not use the public IP, but if you want to expose your OpenShift cluster to the public network, we can use this public IP. Uh, all the cluster related administration will be done by this WAN network. So these cluster administrators or developers that who want to deploy the application on the OpenShift will be connected to WAN network directly. This OpenShift network is not exposed directly to the end user. So, and application user, if you deploy some application and application users want to access this application locally from LAN, and they can connect with the WAN network. Otherwise, you can expose port 80 and 443 to the internet if you want to publish these application to the internet. So these public IP you can port forward to this WAN network. So this is a quick overview what we are going to deploy. I just installed so far this load balancer, Red Hat Enterprise Linux 9, and I did the subscription of Red Hat. And for that purpose, I create the Red Hat developer account. So you can also use the CentOS 9, that will also work, but I use Red Hat 9. And let me show you how I use a hypervisor. So this is my all the virtual machines so far I set up. So this is the HAProxy. So my HAProxy, let me do SSH. So this HAProxy is having two network interfaces. One is that I showed you in the diagram that is connected with this internet enabled network, and this is the connected with the OpenShift network. If I show you the route, it's a static default route. It is pointing to my firewall IP, and internet is working on this machine. Uh, so, and also this machine is subscribed with the Red Hat Enterprise Linux. If you are new with the Red Hat, you can simply create a Red Hat developer account on Red Hat, and they will provide you uh, Red Hat subscription free of cost. I believe they can provide on one account 16 machine you can connect with your subscription to make the uh, to connect your Red Hat machine with subscription manager. You can use subscription manager register, and then you will press enter. You have to provide your username and password of Red Hat, and then it will be connected with Red Hat subscription. So far it is configured, so that's why it's giving me message that it is already registered. So I have DNF repo list. My repositories are working fine, and we have to install some basic packages first of all, because I installed the minimal Red Hat Enterprise Linux. So it is not coming with Vim, it is not coming for bash completion, and it is not having the telnet utility, it is not having the net tools. So it will provide the netstat related utilities. Okay, let's see which I installed or not. Okay, I installed everything already, but just to show you, you must have to install if you install the minimal. And I will recommend the minimal install. Don't use the GUI based installation. So I set up the host name to HAProxy. Now, according to this documentation that is given this in the description of this video, uh, we have to we configure these virtual machines. I will explain you this one, why this is required for the ESXi based virtual machines. There is a feature we have to enable. But when you will create the Red Hat developer account, it will give you a 60 days free trial for OpenShift. OpenShift is not free, it's license based, but now the developer's account can use 60 days trial without support, just to make the POCs. So you can go to console.redhat.com OpenShift account, and you can log into your account. Okay, let me just log in. So here now we are directly landed in the OpenShift, Red Hat OpenShift products. If you go to, I believe, the services, uh, yeah, we don't need to go to under the service. So you are directly under the OpenShift. So here on the left side, you can see the cluster list. So here we will deploy a new cluster. This cluster is already in under the deployment. I provisioned this 30 days ago for some POC. So we will create a new cluster today. Okay, now this load balancer machine, we have to understand how to enable the netting on this machine, how to install the HAProxy, DNS, DHCP, and how the what tools we are going to configure. So in the video description, you can see the uh, OpenShift. This load balancer machine will actually work for these purpose. It will all the command line based administration we will perform by this OpenShift admin and load balancer machine. So it will also perform the OpenShift administration. We will generate SSH key share key pair to, and we will share the public key to the OpenShift cluster so that we can directly land into the OpenShift cluster, because we don't know what is the password actually to get into the OpenShift cluster. So the only way to enter in the cluster is SSH key in the worker nodes and master node. It will work as a router. It will provide the internet to all my OpenShift cluster. It will work as a load balancer. It will do the load balancing for port 80, port 443, for bootstrapping during the cluster installation, and for the API 6443 port access from to the worker and to the master nodes. It will provide DHCP and DNS. So all these things we have to configure. So here I mentioned the first of all install Red Hat or CentOS 9. It is done. I showed you. Then we have to disable firewall D and SE Linux. We can perform all these activities including firewall D and SE Linux, but uh, because this video is not Red Hat administration related, so that's why I skipped this part. So I am just going to disable firewall D and I will disable the SE Linux. So here by default its mode is enforcing, so I will set to disable. We can configure the whole load balancer by using SE Linux, by using firewall D, but if we set up this here, it will detrack us. So a lot of time we need to configure this. If you need the detailed understanding, you can directly contact me by email. So about this firewall and SE Linux. So far, but what I did, I just disabled this. So get enforce. You can see it is enforcing, and firewall is disabled. So I would like to just reboot this machine, and because SE Linux will be in the disable mode after reboot, and here my HAProxy is running. Yeah, it's rebooted. So next we have to configure this complete load balancer. So here we did these two steps, firewall SE Linux disabled. Next we have to make this machine a router. So we have two network interfaces, and we also verified that on one interface its gateway is set and its internet is working. So the second interface that is connected with the OpenShift network, and that will be the gateway of the OpenShift network. We have to install. So far, we disabled the firewall D. We can also do the netting by using firewall. But if we enable the firewall, we need to configure all the ports for whatever we want to open for this load balancer. So that's why I disable the firewall. But it is totally makes sense if you use the firewall D, but that is another level of effort. So what I am going to do here, I will run these three commands. It will install the net filter nf table uh, for the IP tables installation, and it is enabling the service. It is starting the service nf tables, and if I look the status, so you can see its status is active. Okay, now we have to write this IP table rule on that interface that will receive actually the traffic from OpenShift cluster. So 10.10.10.1, the ENS224 will be the interface that will actually receive the traffic. So I enable the netting on this interface, and so this will be the gateway. So that's why I use ENS224. In your environment, maybe this network interface name is different. You just have to change here uh, for your network interface. So this with this command you can validate either what type of IP table rules are configured. You can see in from all the interfaces traffic can in and go out to, yeah, so I did one thing wrong. Actually it should be enabled on the outgoing interface, not the this one. So from here I found the error, because you can see in and out. So I know this is not the out, this is the in interface, and this is the out interface. So let me to delete these rules, I can use -f. So you can see the flush, which flush the rule, and let me now change the network interface to ENS 192. So our network interface is ENS 192, that is having the internet access. So let's see, now you can see any interface that is connected with this machine, if defined as a gateway, will route the traffic to this outgoing interface, any source IP, any destination. I just made a very simple netting rule, but you can customize this with specific source IPs to route the traffic to the internet. Now, netting is enabled. Now we need to do one more thing. By default, uh, Red Hat, the Linux kernel, is not doing port forwarding. So to make your machine a router, we have to provide uh, we have to provide uh, we have to enable a feature in Linux kernel IPv4 forwarding. So now if from one network to another network, IPs, the packets can jump by enabling this feature. By default, this feature is disabled. And we also have to run sysctl-p to recall these new written rule in features in this sysctl to inside your uh, kernel. So now kernel is enabled with this feature. Let me quickly add this one here too. Okay. Next is we have to install and configure the bind DNS. So first of all, we need to install the bind packages. So bind is Red Hat DNS uh, local DNS if you want to set up the bind package. Bind is used. So bind is installed. The configuration files I already configured and uploaded in the Git repo, and you can see the link in the video description. So this directory, the OpenShift setup, I uploaded in the Git repo, and this contains a DNS directory. The architecture that I showed you is also attached in this directory, and this DNS directory, it contains named.conf, that is a main configuration file for the DNS. And let me just quickly show what is this file doing. So actually this file is the DNS configuration. Mean my DNS will work on 10.10.10.1 and localhost IP on this machine on port 53. And DNS can receive query name to IP resolution from any IP of this network, that is pointing to OpenShift network. These are some other features, and if some request came other than the locally defined DNS reverse and forward lookup zone, it will be routed to these public DNS for any internet related name to IP resolution. And here I provide the zone, dot contain the international DNS, and this is the domain name I am going to use for my cluster. It's cluster1.local, the name of my local DNS, and its forward lookup zone file is here at this location, and this is the reverse lookup zone, and its reverse lookup zone file is residing at this will be residing at this location. The rest of all these two files are built in when you will install the bind package. So now what I need to do, just we have to run these commands. If you are inside the directory of this OpenShift setup, so just copy DNS name.conf with the existing name.conf. I overwrite this one and this whole zone directory under the etc named, because I defined this path uh, inside my configuration file on name.conf. So in this file, if you go, you can see these two files I uploaded. Okay, so everything is good. Now I need to enable start and look the status of this DNS point. Let's see, is everything is working fine. The service is active. Okay, perfect. Okay, it's working fine. And our DNS, if I look at netstat-antup, you can see the port 53 is open for localhost as well as for this interface, whatever we defined in the configuration file. Okay, now the next thing that we want to do, we have to, so at the moment, you can see at the moment DNS will still be pointing to the LAN DNS server. You can see this by testing the dig cluster.local. So right now, if I show you the cat slash etc resolve.conf. So resolve.conf on this machine I set up to this public DNS, but so far my this local machine is also working as a DNS. So let me change my DNS uh, in on the WAN interface, whatever I provided to localhost or 10.10.10.1. So I will set localhost. I mean, this machine is also working as a DNS, and it is, I believe, not applied. So we have to systemctl restart network manager, and here look into we have to look into yeah, now it is changed. Now if I ping yahoo.com, yeah, perfect, it is resolving. So and let's look up uh, cnn.com. Yes, it is resolving. So whatever request I am sending for my local TNS, it is resolving. Now the files I added in the public zone, I would like to show you db db cluster local. Okay, so I will show you the files uh, under the zone and db dot cluster1 dot local. Okay, this is my forward lookup zone. Here I defined HAProxy cluster1 dot local because this machine is working as a DNS server, and this name to IP resolution HAProxy.cluster1.local. Its IP is 10.10.10.1. Okay, then the control plane machines. Here the name of the cluster I defined DevOps VU, and the domain name is cluster1.local, and this is the name of the uh, machine. So worker node 1 will be cp1, cp2, cp3, and this will be the cluster name and this will be the domain name. So to install the OpenShift, you must have to define the uh, DNS names with this sequence, mean the machine name dot cluster name dot domain name. Whatever domain you want to use, you can use the public domain, you can use the local domain. It depends on your infrastructure, and these IPs will be allocated to by DHCP to these machines. Similarly, the worker node 1 and then OpenShift internal load balancer. These three entries are mandatory. API and API hyphen init and star apps, mean anything I will write with this with this with the ingress rule I will add. It will be something like uh, app1.apps.devops vu.cluster1.local. So that will be routed to my load balancer. So why is this? This entry is basically for the end user. So this diagram here, the end user, app user. So for the app user, we will also configure this machine as a DNS. We can configure. But the internally OpenShift also want to resolve all the apps defined, deployed inside the cluster. So, and these two entries are also for the internal cluster connectivity, because the API is running on all the master node. So to access the master node, the way is only load balancer. So all the master nodes will send the request for the API to the load balancer, and then load balancer will send back to other master nodes. So the scheduler, the API, the scheduler, the etcd, the controller manager, uh, these all are communicating with the API. So they will use the load balancer to communicate with the API, because API is running on all the master nodes. So if your load balancer is down, your OpenShift cluster cannot work properly, because the API is not reachable from within the cluster and from outside the cluster. So this can be a center point of failure. So in production environment, if you are using this HAProxy as a load balancer, then it should have multiple machines, and on top of this there should be a load balancer or firewall. And you can also replace this whole load balancer with some physical firewall, just like Fortinet or any other F5 firewall you can use. So you can set up this DNS separately somewhere, and you can define the load balancing rules in the Fortinet or whatever firewall you are using. So then etcd, these entries are also mandatory, and where the etcd database is running. So cluster will try to hit these machines on etcd, and for the etcd, and similarly these records are also mandatory for the etcd, uh, and this is OAuth. This is the dashboard for the OpenShift. If someone want to open the dashboard, they can provide the DNS, this DNS, and they can reach to this interface. Similarly, console OpenShift, this is also the dashboard. These both are same dashboard. So these are the DNS resolutions. I create this file, and db dot reverse. In the reverse, what I did, I just add the same entries with the reverse lookup zone, with the same entries, the HAProxy, the API, the init, and control plane and master node. Okay, so the host name of this machine is HAProxy, but it should be host name. Let me set host name HAProxy dot cluster1 dot local. Let me just ping to this one. Yeah, it's name to IP resolving because my DNS is working fine. Okay, now if I ping my cp1, sorry, cp-1 dot DevOps vu dot cluster1 dot local, you can see it's resolving. So far this machine is not up, that's why it's not pinging, but I just want to quickly check the name to IP resolution. DNS is working fine. Sorry, this is -3. And for the worker node, I think I set up the name like worker1, yes, and worker2. Okay, so everything is good from the DNS side. It is configured, it is working. Now move to next step. The next step is we have to, okay, this I give the dig command, but you can also use the ping command to see the resolution of the. Now we have to set up the DHCP. So to install the DHCP, simply you have to install this package DHCP server. Okay, perfect. Now DHCP server package is installed. So DHCP configuration file we have to throw copy from the Git repo I provided you. So I copied that folder here, and you can see. So you can see this file in the I have said the named. Sorry, I have to be in the shift. Yes. So here this is the dhcp.conf file. I will copy to etc dhcp at this location. So what is this file actually doing? This file is a DHCP. It's authoritative, and these are some options. And the subnet that is dealing, this is a subnet, this is a subnet mask, this is a default gateway it will provide, the net mask, the domain name for this subnet is cluster1.local. The DNS IP is same like the gateway. So this interface we configure to resolve the name to IP for the OpenShift cluster. And this is a range. If some MAC address is not binded, so that machine can get the IP from this range. And these are the hardware MAC binding I did with the MAC addresses of control plane. And just to save the time in this video, what I did, I install I just configured the virtual machines. I configured the virtual machines with the specs that I showed you, the hardware specs, and sometime it is taking time to log in. Okay, so here you can see I just configured these virtual machines, master 1, master 2, master 3, worker 1, worker 2, and I have not deployed any operating system. And I will show you the configuration hardware settings. What I did for CPU 20 GB of RAM and 24 GB RAM, and the 150 GB thin provision I am using a hard drive SSD, and I connect this. I have two networks as I showed you in the diagram. So I connect this virtual machine with this OpenShift port group. So this VM network is the second network of the load balancer. If I show you the load balancer, I show you the load balancer. So load balancer is actually having two network interfaces. You can see network 1, network 2. One is going to VMnet and other one is connecting with OpenShift network. Okay, so to save the time, what I did, I configure all these machines. And when you will configure these machines, so that After configuration, their network interfaces will not get the MAC address automatically. So you just need to power on this machine just for a while, and you can then power off again. So this is the behavior of the Hyper ESXi, that it will allocate the MAC address when the machine will power on first time. So the MAC address, I just power on with these machines and power off. So MAC address is allocated, and what I did, I put the MAC addresses of each machine I created here in this file, and I allocate the IP same like whatever I defined in the DNS. Okay, and these will be the host name of these machines. So host name and IP addresses will be provided. Host name, IP address, DNS, gateway, subnet mask, and the domain name. All these will be provided by this DHCP server. So this file is perfectly fine. So I need to start and enable and look the status of DHCP, and okay, it is active, and you can see for this interface there is no subnet declare, so it will ignore this interface, the second interface, because the network I defined the DHCP is only for 10.10.10.0 network, so that it will only work for that interface. Okay, so DHCP is also up. Now we have to install HAProxy, that will actually take the request of application and OpenShift administration API request from outside, as I showed you in the architecture. So HAProxy is already installed. Okay, no problem. Uh, and HAProxy configuration file I also provided. I will show you the HAProxy CFE file. And here you can see these are the max connections, logs, and different parameters about HAProxy, which user and system user and group will be responsible. So these are some default parameter. This is the enable HAProxy stats. It will show you a page on port 9000, and slash stats we will write, and it will refresh after every 10 seconds. 10,000 millisecond mean 10 seconds. And these are the load balancing rules. The front end mean it will receive the request from the WAN interface 1.2.3.50 interface on port 6443, and it will forward these requests to K8 API backend. So this is the K8 API backend rule I wrote, and here I only defined the master nodes. So on master node, they will have this port already open. So if you in future you will have more master node, you can add here. And if any of the master node is not responding, it will not send the request to that master node. It will only route the traffic to working master node. Similarly, the port bootstrapping port machine config. So this is used during the installation 22623. After the installation, it is not required, and it is also pointing to master node only. So here I gave the wrong name. Here I should also write the master instead of CPCP. So these names are just presenting on the dashboard. This is not the actual machine. This should not be the actual machine name. I mean, this is just presentable on the dashboard. So you can write here any meaningful name, but the IP and port number should be correct. So then the port 80, if you are going to expose any define any ingress rule, uh, on port 80 it will be routed to master and worker node. The node, the port will be open on all whole across the cluster, and similarly port 443 will also be routed to master and worker nodes. So let me just copy this file to the actual location, it will override the by default coming file, and we have to enable start and look the status of this HAProxy. Okay, it is active. Great. So here you can see, if I look the status again, you can see it's giving some logs that it is down because it is trying now start looking the worker nodes and master node for the ports what I have defined. But so far our machines are not ready. It is giving error. So you can access the dashboard of this HAProxy. So uh, here, if I show you the netstat-entup, you can see the port 9000 is open on all the interfaces I define in this configuration, and it's mean my IP 1.2.3.50 on port 9000 slash stats is working fine. It's showing me the load. So far you can see the API backend is all master nodes are not giving any response. Uh, Similarly, this is the bootstrap port. All nodes are down. Similarly, HTTP and HTTPS traffic is not coming. So far, the cluster is not ready. Okay. So now what I have to set up. So HAProxy is done. NFS server we will also set up, but not in this video because making this is a different topic that I will explain in next video. So, but I gave in the video description. So now we are good. One thing that I have not explained you so far, that is a special configuration you must have to do in the ESXi virtual machines when you will install the OpenShift cluster. So it will give you an error that the machine hard drive UUID must be set. This is a feature of virtual machine. So when if you are using ESXi hypervisor, so you must have to set your all worker and master nodes only. You will go to the VM options, you will go to the advanced, and here edit configuration, and here I believe I added, let me just search UID. Okay, so what I did, I already configured these virtual machines with this parameter. So you must have to set this parameter, otherwise you will get the error when the OpenShift will be installed. So document in the video description I gave the steps how you can enable this. So here you just search for UUID here. So disk enable UUID true in all master and worker nodes. Okay, this is only for the ESXi hypervisor. Next, we are done with all the configuration. We have make sure all these specs. We make sure this UUID enable UUID parameter. We have now Red Hat account logged in, developer account. Uh, Install the CentOS firewall D, netting is enabled, installed, bind DNS we tested, DHCP we configured, HAProxy is running, NFS we are not done. Now I will go to the actual deployment process of OpenShift. So it's console.redhat.com OpenShift. So I am already logged in. So here you can go to clusters and create a cluster. So OpenShift is deployable with lot of methods. mean, methods are basically UPI and IPI, but on multiple infrastructure. Uh, on Azure or on AWS, on IBM Cloud, on Alibaba, whatever, on-prem. So whenever you are going to deploy on-prem with UPI method, so UPI is user provisioning infrastructure. So pre-existing infrastructure, we must have to use this platform agnostic, and our architecture is Intel based 64-bit processor, so I will use platform agnostic x86-64. So you will go to data center. This option is available in yeah, both, either in the cloud or either in the data center. You will not go in the local, just go to the data center and select the platform agnostic. And here there are, this is a recommended interactive way. This is agent based, but use this interactive way, web based. Now it is the look. It is asking you the name of the cluster. So name of the cluster I gave DevOps VU, and the domain name. We set up cluster1 dot local. So this is the cluster name, this is the cluster1.local. So our complete domain will be DevOps vu dot cluster1 dot local, and before this, all the worker nodes, I mean the name of the child domain, the name of the master worker node will be. So the latest variant right now available, let me just do some zoom in. Okay, so right now the latest variant is 14.17, and my architecture is 64-bit. I am not using PowerPC, I am not using system IBM Z or ARM processor. I am using 64-bit Intel based processor. So I will deploy OpenShift variant little older. I can say 14.15, because later on I have to show you how to upgrade the OpenShift with the newer variant. So I am using this one, and install single node OpenShift. This is also possible. Just give a big node and it will install everything on one node, but it will not make sense for your production environment. So better to use multi-master setup. Uh, Edit pull secret, any images you want to configure, the pre-configured a secret inside your cluster for your registries, so you can provide the secret value here. But I am not using anything. I will provide the secret inside my manifest. I will define my own secrets. uh, Here it is asking for the platform integration. Nutanix, Oracle Cloud, vSphere. So far we are using vSphere, but we are giving uh, we are making a sense that we are going to deploy on the bare metal. Although these are the virtual machine, but think like it is a bare metal based installation servers. I don't want to provide the custom manifest. The IPs will be taken by this by the DHCP I showed you automatically. I can also configure the static IPs, but I will use the DHCP. I don't want to encrypt worker and master nodes. Okay, we are good here. DevOps VU cluster1.local. Okay, next. Now, uh, OpenShift, the new OpenShift is also providing the virtualization, and we can deploy the virtual machines on top in parallel to containers in the OpenShift. I don't want to enable this feature. Install multi-cluster engine. I don't want to check this one. Operator, these are some operators that will provide additional functionalities. Install logical volume manager storage mean the it is good if I want to set it will configure the partition on the worker and master node with LVM. But I will use the default partition structure and uh, data OpenShift data foundation is also an OpenShift product uh, of storage related product. So I don't want to do this. Our target is to just make OpenShift cluster, very basic OpenShift cluster. Later on, we will add these functionalities. Okay, now next, uh, mean here it is asking to add the host. So I will click on add host and to enter in my OpenShift cluster. OpenShift will not provide me the username password. So I have only one way to enter in my cluster by using SSH key. So I will use this machine to generate SSH-keygen. So I am generating a key and it is generated here. The public key is generated. I just need to copy this public key. Private key is also created here and I have to provide here. Okay, uh, show proxy settings. So actually what is happening here, it will generate a dedicated ISO for your cluster that will that is basically based on core OS. Core OS is Red Hat 9, based on Red Hat 9, and it is specially designed operating system, the Red Hat flavor, for running the microservices. It is totally customized for the high performance of running the containers. So now it will generate a special ISO for our environment, and that ISO will already have embedded this key. So when we want to jump into our any worker or master node, this key will be there and we can do a passwordless SSH by using a user core, uh, and we can jump into our any worker and master node. So it is asking me, and here this option is very important. I must have to set a full image file. I don't need to select minimal image and iPixie. Full image file mean everything is included in this in that ISO file, and its size is about 1 GB it will be. Otherwise, if you select the minimal, it will pull everything, download and update the packages from the internet on the runtime during the installation. That will take time. So it's better to use this full image. So now this full image will have this key and generate discovery ISO. So now it is saying me you can download this ISO uh, by using wget command from Linux or by using by directly downloading from this link. So I am using wget on my HAProxy. Then I will copy. Sorry, wget is not there. Yum install wget. So wget, it is downloading. It is downloading and it will take some time to download. Okay, so the image is about to download. So in this session, we are going to close this session because in we just downloaded the image and we will upload this image in the hypervisor data store, and then we have to mount this image in with all the worker and master node, and we will power on the machine, and then the machines will automatically get the IPs and host name and internet, whatever we set up with DHCP, DNS, and netting. This image is downloaded and size is LH 1.1 GB. So I will upload this image, and in next session I will show you how this whole OpenShift cluster will work. So here you can see we provide us the link, so we can close this and we can edit this configuration too if we want to make any changes later on. So you can open this link again by use adding hosts. So when we will power on the machine, so these machines will be reflected here in the inventory list. So uh, this is up to this. We are done for today's videos. So in next session, we will install the whole cluster.